So, after 20 days, I managed to release a video which was completely subpar, in which I rambled on for around 30 minutes. So I guess it's time to add a few words. As I wrote in the description of the last video, I would be making another follow-up commentary with more focus and dedication to specific parts rather than just general nonsensical rambling. I'll try to be more coherent and cohesive in this video, as I'm not making this video for the 5th time, so I do not have to contend with what I tried saying in the past and what I'm saying in this video, since this is the first recording. The lathe, as I said, is a 3-phase hydraulic automatic lathe. It was made, I assume, around 1970s by Habegar, who started making machines around 1937. The hydraulic blocks, as I said, will be retained and repurposed to suit the CNC conversion. I will remake the panels. I'll cast them in aluminum and machine them to shape so they fit properly. As you have seen, most of the panels are missing. I'll have to conduct a more thorough cleaning of the lathe, as is obvious. I haven't been fiddling much with the machine in the last 20 days almost. I have had some other work to do indoors and around the yard. The fall is coming, so there's pruning and trimming of hedges and shrubbery and trees to be done, so that took up some of my time. I have had some work to conduct in the house, which also leached some of my time, and the weather wasn't really on my side, so I delayed working on the machine. The hydraulic tank will have to be opened up. I do not know in which state is it at the moment. I emptied the machine of hydraulic oil, but I do not know, does the plug allow for a complete drain of the tank? The coolant tank, as you have seen, was completely drained. Those two compartments are still a mess, as is obvious. I'll have to inspect all the lines, all the cables, see what connected to what, eliminate some of the sensors and prior ancillary nonsense that the machine relied on to do the job. The revolver is pretty much a fully cast machined construction. As I said, the revolver appears to be a through shaft spindle relying on plain bronze bearings, or at least that's the way it appears to me, due to all the oilers and just the general design. I guess it could rely on roller bearings, needle bearings, as they would allow a decent shaft diameter to be supported and still work as a bearing system of great rigidity, but I assume plain bronze bearings. The ways of the revolver, as you can see, aren't a box configuration, as is the case with the threading slide. This relies on the tapered seat, quite akin to olden milling vices, which had a similar sliding surface configuration, but yeah, it's a bit inverse in this case, although it is a very rigid system, which should allow for maintained accuracy of parts through hundreds of hours of cycles, at least according to the wear generated by the system and imparted to the surfaces. I have been wrong, I think, when I said that the hydraulic powered cross slides, which I assumed were twins mounted on each side of the ways, used to impart geometries with forming tools. I think that the hydraulic cross slide was only mounted on the right side, which is supported by the discoloration of the surface being covered by another matching precision surface. The left side, I think, just carried the threading slide. The headstock mounted hydraulic parting slide will be removed. I will save it for some other machine project I think I have something in mind, but that is another project that I will make a separate video on. For now, it's just a part waiting to be removed. The headstock, as I said, has a 64mm spindle bore diameter, which I have not shown you, as I said, given the automatic collet closing system, which is pretty much in the way. I'll have to take that off. I will not be relying on it to make parts, as I do not intend on running large production cycles where hundreds or thousands of parts will be made in batches, so I have no use of it. I do not plan on applying a bar feeder to the system as the lathe probably had in the past. It simply makes no sense for my needs. The spindle bearings do feel extremely good, and they feel well preserved. I tried rolling the spindle by hand, and while I know that rolling a spindle by hand and applying side loads by hand isn't really a great way of testing the bearing health, I think that if the bearings were in any way damaged or scrap worthy, you would feel it most definitely. You would not even need to side load it. If you feel resistance or hear crunch in the precision bearings, you know that there is no saving them. But the bearings felt extremely smooth, pretty much butter smooth. So that's a good thing, as I assume the bearings would be quite costly to replace. I am guessing that the headstock relies on a angular contact bearing duplex configuration, or maybe a tandem configuration, but I could be wrong. The only thing I'm sure of is that the spindle isn't really using plain bearings, given the lack of oiling system in the headstock. The headstock can be aligned with the rest of the lathe with the set screws in the sides. The whole lathe is extremely precision friendly in a way, given that the whole machine body is pretty much just a mounting surface for the headstock and all the accessories that you will be using. So everything can be tapped into perfect alignment, scraped into perfect alignment. Know that other machines which have more dedicated geometries cannot be scraped and tapped into perfect alignment, but I think that this system allows for much easier achieving of precise configurations and alignments than having to match, scrape, and perfectly align a dedicated geometry machine like, say, a jig grinder or just your average Bridgeport milling machine. It's simply much more work and less reference surfaces to go off of, especially if the machine is worn and you are restoring it, as is the case with most of my machines. I'm not saying that this machine is worn, it does not appear to be worn, but she likely isn't in virgin state as, well, just one of my machines, which I am really lucky to have. The paint, as was noted in the comment on the last video, does seem to be original, which I'm very glad about. I have learned my lessons regarding repainted machines, and I'll do my best to avoid picking them up, at least if I'm not picking them up from scrapyards, with full restoration in mind. That being said, I will partially strip the machine of paint, fix some chips in the paint and other areas that will need touch-ups. I will repaint the machine once everything is done. It will be, I think, RAL 7011 or 7013. I cannot really recall the paint code. The machine Graublau color code, but yeah, I prefer that paint color, and yeah, that's going to be the finish of the machine. But as said, the machine does seem to be retaining its original paint, which is a good thing, as any damage or anything else isn't actually hidden by a sloppily splattered layer of new green paint just to, you know, make the machine appear in perfect operating order, which was the case with one of my machines that I actually picked up, not from scrapyards. and quickly learned that I haven't actually received as perfect of a machine as I originally hoped for. But yeah, you'll see that beauty in time. It is a surface grinder, so that is one of the machines that I will have to contend with relatively quickly, as I want to utilize the large capacity of that surface grinder to generate some new components. The grinding and milling head. I will also have to remake this missing hydraulic cross slide for forming tools, although I am not sure if I will utilize that slide as a mounting surface for one of the aforementioned heads, as that would be a nice spot to put a secondary operations head. The electrical cabinet will pretty much have to be remade entirely. Not remade, I will retain the compartment, but the arrangement will be sorted out, as most of the cables are pretty much scrap copper at this point, being cut off from their sensors and whatever they were feeding power to or signals from. So that leaves me with a nice amount of electrical work, which I'm not an expert on. The threading slide, as I said, will have to be inspected, checked, remounted when the wear has been ascertained or the lack thereof, which would be nice. The threading cross slide was already removed from the machine when I first got into her, so I have not really seen the precision mounting surface that rested on the ways, so that will have to be looked into after I have assembled my work in progress custom engine hoist that I'm making for the last 8 months. I'm not really delaying it, but I have been running into some issues with my TIG welder and just general nonsense that prevented me from completing that project in its entirety. As you have seen, and as I said, the whole lathe, practically everything except the finished part compartment, is hydraulically actuated. Every motor is a 3-phase motor, which isn't a problem in my case. I have access to 3-phase power, so that's a good thing. I will not have to contend with conversions and similar nonsense. I'm quite interested in the... Give me a second. I'll take you off the tripod. As I said, I'm quite interested in the main spindle power compartment, as it is an interesting complex mounted in here. The hydraulic blocks I have covered. They're just the hydraulic valve control for the forming cross slides. But what fascinates me more is this little hydraulic operated casting that seems to be just a belt retention system, but isn't really. At least that's my speculation. As you can see, this larger pulley has a little split in it and has this threaded bore and another one down here, which to me indicates a planetary gearbox construction within the pulley itself, something akin to the pull gear. And I think the belt shifting casting with its rollers and this large rolling pin pulley allowed the lathe to change speeds pretty much just using the pulleys. Then you have quite a substantial gearbox that the pulley is mounted onto, which has another of these pulleys with planetary construction. You have seen it much better in the inserted little portion in the last video. And there we have another of those belt shifting arms castings. I'll not be trying to capture it better on the camera at the moment, as I said, you have seen it already. So yeah, I'm quite looking forward to taking that all apart and inspecting it. I'm interested in the internal workings of the gearbox. I think it's just a regular 2-shaft and some gears construction, but I cannot really speculate on it, as I don't really have access all the way around it, nor insight into its construction, given that I do not have a manual for this machine. This little fan blade will have to be beaten back into shape. This additional bearing carrier is quite a nice thing, given that it should completely reduce any lateral loads on motor bearings and gearbox itself. I'm estimating the main spindle motor to be around 2.75 horsepower, just on its size. It has absolutely no markings or any tags or plates at all to it, so it's relatively hard to speak or deduce anything about it other than just by looking at its size and comparing it to other 3-phase motors that I have seen. This little junction box will be scrapped. I have a nice collection of castings, as I said in the last video, some of which are quite lovely, I think magnesium possibly, cast junction boxes, which actually have nice sealing configurations and sealing elements, rubbers and stuff, so that will be a much better thing to put into this machine than just this bent sheet metal. As you can see, the casting of the machine is quite substantial. Nothing is really thin, which is a lovely thing. Yeah, as you can see, this little rib, a reinforcing rib in the back, is quite substantial. It's tapered, as you can see, which makes sense for a cast part, but it's over a centimeter. It's pretty much half an inch at the front end, widening toward the back to almost 3/4 of an inch. The whole machine has a lot of reinforcing geometry. This little gutter, as you can see, is actually coolant routing or coolant drain. Another coolant drain, as is obvious from the construction, is on the other side, pretty much hidden by the threading slide. But yeah, both sides have drains for any excess coolant. Speaking of coolant, I will not be using water-based coolant. I will be using mineral oil, like the automatic transmission oil or something like that. Anything that is detergent free and that has absolutely zero risk of inducing rust over time by creeping under precision surfaces. I'm a bit baffled by the fact that the machine has so many manual oiling points. Even the threading slide has them. I do not see any at the moment, but yeah, you can see one over here. I would expect a hydraulic system to have automatic lubrication just to make full use of the hydraulic system itself. My surface grinder is a hydraulically operated machine, and there are no oiling points, literally. Everything is connected to the hydraulic system and is supposed to be oiled by it as the machine is being moved, just to, you know, maintain a constant layer of lubricant between the precision surfaces. I think I have covered everything. You will see me cleaning up the machine. There will be another video of me dancing with the mop, as the lathe is pretty much still a mess. I cannot really be showing that on video any longer. It's just disgusting. So I'm going to linger on the most disgusting part of the lathe, just to drive the point home. But yeah, I'm delaying that as well because as long as the threading slide is here, I cannot really have proper access to finish cleaning the lathe. The rest of the things I can remove, take off by hand. But yeah, as I said in the last video, this whole bit is quite the monster. Much heavier than it appears to be. I think this is pretty much it for this installment. As I said, this is supposed to make up for incoherent and incohesive rambling of the last video, which covered little and provided almost nothing of substance. Also, if you want to provide anything of substance regarding any of these parts, if you have any prior experience with automatic lathes, it is most welcome. As said, I have zero resources on this machine, zero information. I have picked her up because I absolutely fell in love with the design, and I assumed that the machine would be an amazing addition to my shop once fully operational and converted to CNC operations. But yeah, I guess this is pretty much it. You have seen the machine, you have seen what's missing. I think I covered everything. If I haven't, I guess I will cover it in the next video. And yeah, you will see me when I upload the next video. All the best and bye bye.